Hi friends, we all know computer stores data as binary digit. Binary digit are nothing but 0 and 1. Every input you provide either through the keyboard or through the mouse or scanner or any input device, every key press, every mouse click, every scan will be stored as binary in the computer. Computer memory are two types. One, primary memory. Primary memory is of temporary in nature. RAM chips, for example, are primary memory storage type. Primary memory stores data in the form of transistor state. Transistor state on represents 1. Transistor state off represents 0. The moment power goes, everything becomes 0. So all the data will be lost. That is the reason we need secondary memory, the permanent storage like hard disks, CD-ROMs, tapes, pen drives, etc. All these devices store data permanently irrespective of the power switched on or not, whether it is connected to the computer or not. Secondary storage devices uses magnetic fields to store data. Hard disk has tracks and sectors. The hard disk header gives access to the different tracks, and the spindle gives access to the different sectors. One byte equal to 8 bits. We all know bits are zeros and ones. So one character is stored in a byte in general. For example, the capital letter A is considered as 1 byte, which is represented as 8 bits in the computer memory. American Standard Code for Information Interchange ASCII defines a code for each character. For example, capital letter A is given ASCII code of 65. The 65 converted to binary is 01000001. This is the ASCII table. ASCII represents its codes in 8 bits, which means in 8 bits, a maximum of 256 combinations can be arrived at. ASCII can only represent 256 characters. If we want to store characters of multiple languages, smileys, emojis, etc., ASCII is not sufficient. ASCII can only represent English alphabets, capital letters, lower cases, digits, and special characters we see on the keyboard, but nothing more. It cannot represent characters in multiple languages or the special characters like smileys, emojis, etc. In order to provide support for multilingual languages, Unicode has been introduced. Unicode represents characters in 16 bits. That means Unicode can represent 65,536 characters. So almost every language, every written language can be represented in Unicode. In general, kilo means 1000. But in computer parlance, as the computer stores data in binary, we should take it the nearest size. As 2 power 10 is equal to 1024, so 1024 bytes is considered as 1 kilobytes instead of 1000 bytes. 1024 bytes to be taken as 1 kilobyte. 1 kilobyte can handle about 200 English words. That means a short email can be stored in 1 KB of storage. 1024 kilobytes equal to 1 megabyte. 1 megabyte can store about 100 to 250 photos depending on their resolution, or about 25 MP3 songs if we consider each MP3 song as 3 to 5 MB each. 1024 MB equal to 1 gigabyte. 1 gigabyte of storage can hold whopping 0.7 million pages of text files, or 15,477 images, or 17,552 PowerPoint slides. 1024 gigabytes is called 1 terabyte. 1 terabyte of storage can hold 250 movies, or 500 hours of high definition video, or 6.5 million PDF documents. 1024 terabytes is called 1 petabyte. Internet giants like Amazon, Google, Facebook, they maintain about 100 petabytes of data each. 1024 petabytes of data is called 1 exabyte. Several hundred exabytes of data is transferred over the internet every year. Here we are saying every year, which means not a single company can store exabytes of data. 1024 exabytes is called 1 gigabyte. All the data in the world together is just a few gigabytes. So here we can see how many characters or how many bytes can be accommodated in a yottabyte or a gigabyte or exabyte. There are so many such names which represent huge amount of data, but we do not need all of these as of today. There is no practical use of such a large measurement as of today. Gartner research says world data is doubling every 2 years.